Cosmic snowmen, how gravity quietly built worlds beyond Neptune. Out beyond the orbit of Neptune, sunlight fades to a cold blue glow and the solar system becomes a vast archive of its own beginnings. In this remote realm lies the Kuiper Belt, a sprawling ring of icy debris left over from planet formation 4.5 billion years ago. And scattered throughout this frozen frontier are some of the most curious bodies we've ever seen, worlds shaped like cosmic snowmen. If you like my videos, subscribe my channel and press the bell icon to turn notifications on so you keep getting all the major advancements in science and technology. And don't forget to like and share this video with your friends and colleagues. The mystery captured global attention in 2019 when NASA's New Horizons spacecraft flew past the Kuiper Belt object Arrokoth, formerly nicknamed Ultima Thule. Instead of a single rounded rock, the probe revealed two gently fused lobes, like two snowballs pressed together in deep space. Since then, astronomers have realized that roughly 10% of Kuiper Belt planetesimals share this contact binary shape. That fraction is too large to dismiss as coincidence. Something fundamental in the early solar system must have been sculpting these forms. For years, the leading question was simple but profound. How can such delicate structures form and survive? High-speed collisions should shatter icy bodies, not preserve two near-perfect spheres joined by a narrow neck. Violent impacts seemed inconsistent with their smooth, intact geometry. A new generation of simulations now offers a compelling answer, one rooted not in chaos but in quiet gravitational choreography. Researchers modeled the collapse of pebble-sized material within the young solar system's protoplanetary disk. As dust and ice clumped together under self-gravity, some collapsing clouds didn't form a single object. Instead, they fragmented into two bound clumps orbiting one another. Over time, those partners spiraled closer. Crucially, the new simulations treated them not as fluid blobs that melt into one sphere, but as solid, structurally coherent bodies. That distinction changed everything. Rather than smashing apart, the two objects drifted inward gently, touched at low velocity, and remained locked together, preserving their individual rounded shapes. The result? A snowman-shaped world, born not of violence, but of gravitational settling. This mechanism, gravitational collapse followed by gentle contact, beautifully explains both the frequency and fragility of these objects. If about 1 in 10 planetesimals are contact binaries, the process that formed them cannot be rare or exotic. In the sparsely populated Kuiper Belt, where collisions are infrequent and orbital speeds are relatively low, such structures can endure for billions of years with minimal disruption. The implications stretch beyond mere shape. These bodies are time capsules. Because they formed early and evolved slowly, they preserve clues about how the first solid building blocks assembled in the protoplanetary disk. Their structure supports a picture in which planetesimals emerged rapidly through gravitational collapse of pebble clouds, rather than through slow, incremental sticking alone. In other words, the outer solar system snowmen are not oddities. They are fossils of a formative era when gravity quietly gathered dust into worlds. As future missions venture deeper into the Kuiper Belt, we may discover that Arrokoth is just one of many such primordial relics. Each new flyby could refine our understanding of how planets begin, not with explosions and impacts, but with the gentle, patient pull of gravity shaping ice and rock in the coldest reaches of the